That's right. Yes. I I work at the International School of Toulouse in the primary section. I've taught there since 2003, in fact. I'm from London. And this year I'm working as a STEAM coach with other teachers. Obviously, things have changed a bit since lockdown. I'm helping in different year groups. But other than that, I've been a teacher in classes right from year 1 to year 6.
Brilliant, thanks. Just realized my mic was off for that first minute or so, and someone, so I was just saying in the intro that, this is kind of technical. There's some things that go wrong, but it's cool. We're all rolling now, I think, as far as I can see.
Can people hear us?
Yeah, they can hear both of us now, so I can see that on my levels. So yeah, fantastic. And this is, as I said in the intro, it's a moment I'm really, really excited about. It's like hands-on maths, using manipulatives, using Cuisenaire rods is absolutely one of my most favorite ways of teaching maths. It's there's so much in it. So perhaps you could let's say, so it's very typical for me to have parents who have bought some Cuisenaire rods and they have not done anything with it with their children, or they may have their grandparents' Cuisenaire rod set. And this first stage, what would you do in that very, very first stage when the children are introduced to the rods for the very first time?
So even if they were older children, say year 4 or something like that, I'd want them to play with them first of all. And definitely if they were down in year 1, a few sessions of just free play, entirely free play, is great. I think that kind of sets off I think it's appropriate for that age, especially, but it kind of sets off the use of them as a playful inquiry, rather than, this is partly my pedagogy, I suppose, rather than following instructions. And I want to try and keep that spirit of inquiry, of playfulness, alive through it all, really, if possible. Can I share a screen and I'll show you some of the things that young children do?
Absolutely, I'd love to. Yeah, we already have a couple of users. So I think we have Robin from Zambia and Rebecca in Cumbria.
Let's just get something like that for you. Here we go. First, Cuisenaire. So here's I just say make something. This is quite a few years back. I don't think this was my class. I think I asked to go in and do it with them. Although I later taught them 3 years later with their teacher, I could show them the pictures they'd made 3 years ago, 4 years ago. So this is the kind of thing they might do. And it's probably quite hard for some people to tune into it, but there's some interesting things going on there. You see children like lining things up. A lot of children are, and that's kind of lined up as well, isn't it? That yellow thing. They're obviously already thinking about the sizes of them, the relative sizes. Look at that tower, how the rods get smaller. They're making names. Again, lining up, creating a house. A lot of lining up going on there, some triangles. This is actually something I use to create, say, a person of a certain size later on. So the ideas from the children, what they like to create, is actually really informative for good approaches with the rods. This is an interesting one too, because the staircase, you do a lot with the staircase. I was just using it the other day with some year 2s, and asking them to make it with particular colours, and which stairs were possible. But it's great that right from the word go, these children were using that, the staircase. Another nice tower. So you get the picture of the kinds of things that children might do just with playing freely. A few more instances. It looks like a swimming pool.
Ah, nice.
And I think the key thing comes out here already, that children in their play are actually very mathematical. And the mathematics isn't usually counting. It's to do with arrangement. It's to do with the lengths of things. Here we've got the lengths being all aligned. It might be to do with symmetry, like the little house at the top there. It might be to do with some kind of pattern going on. And look at the nose of that cat there. And these patterns and arrangement become intrinsically mathematical. So often you find that from the play, your next few lessons, and the idea of enclosing things as well is very prominent. Putting a line around things. So it's almost like a set, isn't it? And things that are inside and outside a set. It's all and look at what's happening there. So even before I've given any instructions, there's something very, very mathematical happening in these just free play moments. And of course, you don't have to kind of analyze that with 5-year-olds, because these are 5 and 6-year-olds. But it's worth tuning into what they are doing there. And you could bring a picture like this to the children and say, maybe after a few lessons, you might say, look at this one here. We've got the brown rod, and Joe, whoever, has made other lengths next to it that are exactly the same length as the brown rod. And that's such a brilliant starting point.
Because they have this
sharing that, shall I?
innate, and that's such a good point actually, because when I started using Cuisenaire rods, it's around 5 years ago or something, and I would say this is, people can learn from my mistakes here, is that for the first 2 or 3 years I wouldn't do this very, really important stage of free play. I would go straight into doing maths with it, like putting the staircase and start doing number bonds and stuff. And I often get students with dyscalculia or special needs, or even just who are very disconnected from maths. And the moment you mention maths or mathematics or any kind of thing, they have this anxiety reaction. And if I say we're going to do some maths with Cuisenaire rods, then they've gone into a different headspace straight away. So what I now realize is that you just get them, just play with them as long as it takes, and that stage is really, really important. In
situations like that, I find that the whole class is doing it. There's not, even though those kids didn't know me, there weren't any ones that said, "Oh, I can't do this," or
right.
Everyone could find something. And I think it's partly having a physical object. In terms of play, they're very experienced, in younger years of playing with things, whether it be outside or indoors. And they've got a huge expertise in handling objects and thinking about their length and their arrangement. And it's one of the kind of strengths of Cuisenaire rods that they work through length. Length is their thing. They're not about the number of things. If you had cubes, you'd be counting. They're not really about counting. And so they build on children's experience with planks and crates and tires in the playground outside, and all the things they've been doing, with cups and saucers and so on in the classroom. They've got experience, and they can just get stuck in with that background. Another thing about them is that I think if you want to have a kind of inquiry approach, often you'll be faced with a problem, and one bit of advice might be just to do something with the problem. Because often you're faced with the problem, you think, where do I go from this? And doing something with abstract numbers is quite hard, with symbolic numbers. And you can understand that people could hold back from that. But doing something with little bits of wood just almost is irresistible. If you just put them on the table, if you just had them in the corridor, children would go over and want to touch the little bits of wood. There's something very appealing about it.
Yeah.
A bit plastic for that matter.
Yeah, it's
And so it kind of invites exploration, it invites inquiry, and just ad-libbing, which really is a very kind of basic mathematical approach. You know, if you're stuck on a problem, just try something specific.
hmm.
And so it's kind of getting kids right from an early age to do that.
Yeah, and I've seen some fascinating stuff come up actually. You can get an insight into what they are into actually. You know, I've had one child who's into insects, so just
Mm,
built a very complicated looking scorpion that there's no way I could build. Or I
mm,
had this example, getting hands on straight away as well.
mm,
A 7-year-old child just tell me, well, that's a carrot.
mm. You've
And
got an orange one with a green one on top there.
yeah, I'll actually
Yeah.
switch to my second camera. I'll get hands on
Okay.
straight away, and you can see that
Mm,
that's the one I've got here,
mm,
the orange and green, and so you know I've got your book from the ATM, and it's
mm.
actually in that book I got this real insight that you need to let them free play, and then
Yeah.
what I believe you're waiting for is a crucial moment, right, until they play before you can transition into kind of doing more mathematical
I
stuff.
don't know if it's a crucial moment. It's going to be different for everyone, isn't it? You've got a whole class. You can't time it that exactly, but
Mm,
you definitely want them to play. And you'll see, I mean, I believe our teaching should be based on what we see the children
right.
doing.
Yeah.
Um, forget assessment and everything, any long name for it. We just want to see what kids are interested in, what they understand through
Mm,
watching them and listening to them.
mm,
So, and I'll give you another example. I think this wasn't straight at the beginning, but someone made, I think it was a kind of something like this. And they said, it's I think they said it was a ham sandwich,
right.
and I said, what about the other colours? What are they? And they said, oh, the white is cheese, and the green is lettuce, and the red is tomato. And that was great. And we were kind of ready to do subtraction then.
Yeah.
And so I just did some games like this. I said, oh, can you make some sandwiches with things missing?
Right.
And, what ingredient is missing in your sandwich? And so the class all made sandwiches.
Mm,
We all made sandwiches that lacked one of the middle bits. And it was a great way of beginning subtraction as difference through the children's own ideas.
mm,
So it didn't come from me. I think, especially if you can allow children to lead the way.
mm,
I've got ideas of territory I want to cover, but if I can see ways that what the students are doing already is embodying the content I'd like to visit, that's fantastic. You're going to say, oh, that's Anna's sandwich. Can you make a sandwich like Anna, but maybe leave a bit out, and we'll try and work out what bits are missing. Or you could play that as a game.
yeah.
I'm probably jumping ahead a bit there because that's not the first kind of work I would do with them, after play subtraction. But that's just showing how children's interests, like the carrot, you can build on that carrot.
Yeah. 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 You get a real insight into what they're thinking in some ways. Like this is that's what they are paying attention to. That's what their imagination has perceived with and brought to the surface through the manifestation of these Cuisenaire rods in front of them. Yeah.
And kids have a real inventiveness. There'll be lots of pictures, but there'll also be the things that are quite geometrical and abstract. And all of that is kind of food for learning. The book, maybe we should put a link to it, but the book was with Helen Williams and Mike Ollerton, and Helen does a lot of work she's a real expert with early years. You should get her on, actually.
Yeah.
And so it was a fantastic collaboration. We all had basically an inquiry approach to what we do.
Right.
Mike primarily works with secondary, where we dipped into primary 2. And so we said from early years to adult as a kind of subtitle of our book, because we felt and still do feel that 4-year-olds can be playing with these things, and also adults can. There's some wonderful examples of things I've done and other people have done that are kind of really advanced, but using the Cuisenaire rods to illustrate them or to explore.
Yeah. No, I've got some adults that initially, what is this kind of childish thing that I'm buying? But all they see is these rods from 1 to 10 with different colors, but they don't realize. I've had parents buy it and then not know what to do with them, but you can do so much with them. And I know you can do that, like Pythagoras theorem. You can do all sorts of proofs.
Look at triangle inequalities and so on.
Yeah. There's loads of things. We can use them in secondary. Ratios, obviously. There's tons of things. I think these are really, really phenomenal, and I'm actually just getting. I'm a novice teacher of it, really, so I'm just getting into it.
You're very humble there.
No, genuinely, please treat me like you would one of my pupils. I mean, I'm being really honest here.
Well, I should say too, I'm still learning, and I'm very keen. I'm keen on Twitter, and I pick up loads of brilliant ideas from other teachers around the world, and it's mainly through there and through blogs and some reading of books I've picked up my knowledge. But it's great to share, isn't it?
Yeah. So this is going live right now. So if you're tuned in live and you have a question, just reply to this either on Facebook or on Twitter. You can ask Simon any questions. We're getting some nice comments just of people using them. Actually, we have Mikhaila is saying, I'm hoping to develop my use of Cuisenaire rods during lockdown. Gave one of my students homework, getting his mum to play with them and make pictures together. I get that. Actually ask the parents to have a play, the child to have a play, really, and mum's kind of the photographer, and then send me photographs between. Brilliant. And then
well, on that note, I mean, if you don't actually have Cuisenaire rods at home, there are some good apps with Cuisenaire rods. There's the one from Enrich recently. They've upgraded it. It was a Flash-based one that was a bit... Flash isn't really helping very much at the moment. But they've done a new version, which is lovely.
Right.
There's also Braining Camp, which is normally a paying site, but in lockdown, they've made all their lovely manipulatives available to people. So maybe we could afterwards just put some links to the virtual Cuisenaire rods that people could use when obviously families don't all have them at home.
For sure, yeah. I've had someone ask about the link to the book as well, so we'll put that and all the virtual manipulative sites you recommend. We're going to be doing a little bit of virtual manipulatives right at the end, where I'll show you how I do it, at least on Bitpaper, and we interact. But that's kind of rushing ahead. Okay, so and then I think we're now like little practice school. You did a little exercise with me where I got to hold some rods, and presumably that's like that's one of the first things you do, right?
So do you want to grab these three, the white one and the red one and the green one?
Yeah, absolutely. I'll just switch to my other camera. And there we go. So this is my camera, and that's Simon's camera. So I've labeled it Cuisenaire Cam Simon.
And the hello one.
Yeah. Okay, I should have labeled mine as well here. That's there. And so if you're doing this at home, you could get involved as well. I am actually just going to clarify that.
So actually, you didn't really need to put them on the table too much, because I'm going to ask you to actually pick them up.
Right.
And can you put them behind your back?
Okay.
So I'm kind of talking to Atul, not as an adult, but kind of as I would to a child here. He's assured me he's okay about that.
Completely fine. Yeah. Emmy Howe said, think through the eyes of a child. So that's...
Luckily you're not feeling patronized. So obviously color isn't intrinsic to this. It's about having a label for the length.
Right.
And so we're getting a sense for the length of these things. Can you bring out, from just by feeling, could you bring out the longest one?
Yeah. So this feels... Okay, I think I've got it, yeah. All right, this is the big moment.
Oh, let's see. Ta-da, the green one, great.
Yeah.
Okay, should we try again?
Yeah.
Okay. And how about the middle one now, the one that's in between in length?
Okay. I'm gonna trust my sensory motor system, whatever they call it.
Yeah.
I think I've got it. It's almost like a leap of faith, this.
Yes, it's great.
That's lovely.
Good. I'd obviously get kids, you can relax now, to pair up and to play this game. And we start to add in a few more, try it with the longer ones and so on. But the idea is to get familiar with the colors. Obviously, some children will be colorblind, especially red, green. But usually there's a difference in tone of the two, just as there's a difference in tone of, those are quite close even for us, aren't they? In fact, I've got some old ones in my set that are really close. I think I must go back to the 60s, that one. But, you know, to get used to the length, to associate them with the colors work as a kind of handle for instant recognition. So that, you know, I'm going to see there, after a while, I'm going to see that 1 + 2 is 3. If I was saying last time we spoke how I quite like the idea of if they were made of different materials or felt different to touch.
Yeah.
It would be really nice for someone with impaired sight, wouldn't it? It would be, you know, if that felt, if it had ridges on it and another one had dots on it, and you know, you could actually feel them. Because the point is to recognize them, and so you're not doing any. There's no need for counting. You're kind of bypassing counting and working on length. But the color is just a label for instant recognition.
I mean, there's something really, for me, in that moment I was doing that, there's something really profound about it, because one part of my brain was saying, actually, do you really trust this is going to be the right one? I mean, especially like live streaming. It's like, you better get this right, Atul. And like the moment I reveal it, it's a matter of trusting, like the way you felt it to be the right one, and it confirms the color, and there's like so many things. And I've never done this exercise in my duties. I just go straight into the color, really, essentially, and like manipulating them, but not like actually really just not being able to see them and feel them.
Helen does a lovely thing. Helen Williams, who worked on the book with us, she does a lovely thing where she, and I've tried it myself, where she just asks the children to find 3 different size rods. They don't have to be any particular size. And she tells the story of Goldilocks and the 3 bears. And at each appropriate moment, when she's saying the big bear, she'll ask them to hold out the big rod. And when it's the little bear, she gets them to hold the little rod out, and then the baby bear. You know, this is with 4, 5, 6-year-olds. And again, it's similar to what you're doing, but it's kind of linking it with story and just having a good time. And some children want to have Goldilocks as another thing as well, but you know, the main thing is the sizes and the bears and so on. So there's lots of ways of getting really used to the rods, just as a tool that they're familiar with. It does need some time just to familiarize. Older children can get round it, and they say, "Oh, what one is what's the yellow? What size is that?" And I usually just say, "Go and work it out," because you can.
Yeah.
But also the staircase another way with the staircase, again, my play is I say in pairs, make the whole staircase, and then one of you shut your eyes, and the other one take one away, and then the partner opens their eyes, and can you work out which one is missing from the staircase? So loads of games like that to get familiar. They might see the size, the step is bigger there. That might help them, or they might actually remember the color.
Right.
And soon the colors get quite familiar to them, the relative lengths. They are obviously 1 centimeter, 2, 3, 4, 5, 6 long. So they have a kind of integer length thing going on. Should we move on to, should I talk about how I first do equations and
yeah, absolutely. Yeah, we've already had some people, I suppose, are a little restless. Can we see some more of the middle school uses and triangular inequalities? So I guess people are kind of, let's dig into the abstract symbolism written equations, etc., which is exactly what we had planned here.
Shall I go to the beginnings and maybe look at triangles later on? And touch on that briefly.
Yeah, let's go with the language, symbolism, equality, equations.
Good.
Yeah.
Okay. So you saw with that play, we had someone using the brown rod, and they were laying next to it some rods that are the same length. We call that a train. That was the rods were created by Georges Cuisenaire, who was a Belgian.
Right.
And then a guy called Caleb Gattegno, who was really active in the mathematical world, popularized them. He visited Cuisenaire, and he was amazed at what the kids were learning with them.
Right.
And he popularized them, and he would call that a train. So of rods end to end. Now, actually, I kind of usually, when I start off, it will be smaller trains.
Right.
It might be something like that. And the way Gattegno did it was he actually started to talk about the colors rather than the numbers. Cuisenaire started with the numbers, but Gattegno would start with the colors.
Right.
I think both work really well. And I'll just talk about the way of starting with the colors because it's got some advantages. So for weeks, you maybe would say, can you do this? Can you make them? And you talk about them and say, the purple one is the same length as the red and 2 whites there. And then maybe after you've done this for a while, you might write that up on the board, purple, and you might use the equal sign for being the same length.
Right.
They will have met equals by the time they're 5. They've seen that in long sentences or equations. But we're kind of using it slightly differently here. And after a while of just writing the words, maybe you say, look, can I just write P instead of purple? Just to be quick. And then we'll do, what should we do for white? Well, we'll do W. And at first you might just write down the letters. And then maybe a little while later, quite soon perhaps, you might say, look, we're adding them together. When we put them together, we're adding them onto each other. Right. And the sign for adding is that plus sign, add sign. And so we've got this equation, or a number sentence.
Yeah.
It's not really a number sentence, is it? There's no numbers. Let's call it an equation.
Equation, yeah, equation.
Yeah.
At this point.
And there's something lovely about that already, that it seems to start off the idea of equality on the right footing. Because what children often see is something like 1 plus 3 equals 4. And the equals is always over on the right-hand side.
Yeah.
And it's as if they're pressing the equals button on the calculator. It's like, I've put in my 1 and 3, and now I want to see the total. And equals begins to mean, now here's the answer.
Yeah.
And, you know secondary maths, you want equality to be seen as the thing on that side is the same as the thing on the other side.
Yeah.
It's not about here is the answer. It's about these two expressions are equivalent, are the same in some way.
Yeah, that's so profound, that idea. I mean, we had Anne Watson a couple of weeks ago on a group panel, and she mentioned that by secondary, this equal just becomes give me the answer. Like equal means the answer, but what this is a very really clean literal representation of equality. That,
Yes.
They're the same. They're the same length, actually.
Yes. I do the same kind of thing with area using pattern blocks, where I might get the hexagon, and then I can get maybe 6 triangles, and we see that's not very good triangles, is it? We see those two are equal in area. So it's this idea of seeing equality not just as numbers, but as areas, as lengths, and so on. And really getting a feel for equality, meaning, in some sense, these two things are the same.
And Anne also mentioned, like, the example you use with are so important. And I remember in our test call, you would say, you'll do it the other way around as well. You'd say 4 equals 3 plus 1.
Yeah.
Where you really lead.
I remember there was a really able kid he was very confident in maths. He's always had a lot of experience with it. But when I wrote for something like 4 equals 3 plus 1, he said to me, "That's wrong."
Right.
And I said, "How do you mean?" He said, "Oh, you've always got to have, that's the equals isn't there. The equals has to be over there on the right."
Yeah.
And he just always seen the equals, on the right-hand side of the equation. And I just, since then, and slightly before, I think, I've made an effort, and it's actually had to be quite a conscious effort to sprinkle in lots of versions of the equations where you've got the equality sign, the equal sign near to the left-hand side. So we would do number of the day, and it would be day number 80, and I'd make an effort to say, okay, it's 80. What is 80 equals to?
Right.
And someone would say it would be 10 plus 10, etc. On that side. And soon enough, they get familiar with it. This boy who was, really horrified that I should write it out, he got used to it quite quickly. And it's just very empowering. The children, after a while, get able to write these. So I start with just small ones, so they know their letters better than they know their numbers, really. So we know W for white, R for red, this is G for green, E for pink, and there's quite a lot you can do with just those 4. And so they'll write in their books some equations that they themselves have made. Another thing you can do is obviously you can explore all the ways. Perhaps you'd like to have a go at this.
Yeah.
Would you like to get the pink one or the purple one?
Yeah, sure.
And see what different ways of making the same length as that purple one you can find.
Perfect. I'm just going to dive into. So that's my camera. Pink. Light green. White. Okay, I think I got that. And you want me to write out the...
Well, you don't need to write them for now. Why don't you just try and find other ways of making the same length?
Oh yeah, okay, yes, of course. So I'll go with these. I could also...
People often do this with 10 because we kind of like working around 10, but actually 10 has got so many ways of doing it.
Yeah.
There's not much chance of maybe later on, but there's not much chance of doing it exhaustively. And it's quite nice saying, have you found all the ways?
Yeah.
I think that's a really good question, and it's great to find different embodiments of that question, and then to say, oh, but someone else has found another way.
Right.
There is another way there, actually, you could try.
Presumably, this is...
Oh, you're going to go, okay, so you're counting it, if there are different ways round, you're counting it as a different way. Okay, yeah.
Yeah, I'm going for the commutative...
So green plus white is different to white plus green. Yeah.
As a yeah, on the order it is anyway.
Yeah, so we're counting orders as being different. How about with a 2 and some 1s?
Yes. I missed that. I think that's called being live on air.
Yep.
And
well, you're watching a lot of things, Atul. You've got your hand on the steering wheel here, so.
Yes, now I'm watching. That's my excuse. I'm watching all the chats and doing the stuff.
No shame.
And the cameras and everything.
Given as you're looking at different orders being different, you've got some other possibilities there, haven't you?
Yeah. Let's dive into. Actually, no. Let's make it more interesting.
Oh, so what you're doing there, you're kind of doing it systematically.
It's pretty random at the moment, but I suppose the system is emerging.
With the 1s and 2s, yeah.
Yeah, I suppose. Yeah, that's the logic. Yeah, I'm just using the 1s and 2s, and yeah.
And you've got one more possibility there, haven't you?
Yeah. So I would have the
Great. Atul, I'm sorry to put you on the spot live.
That's fine. It's all good. It's all good. As I said, you can just treat me like a pupil. I'll look through the eyes of a child.
Yeah. I wouldn't do this with a child in front of the class.
Live on the internet too.
Not putting children into a position where they might feel uncomfortable.
Yeah, no worries. It's all for the greater good.
I know you're up for it.
Yeah, absolutely.
How many ways have we got there? That looks like 8 ways, is that?
1, 2, 3, 4, 5, 6, 7, 8, including the purple 4.
Yeah. That's interesting. And it's worth, I mean, this is something with older students you could explore maybe. What if you got the yellow rod, the one that's 5 centimeters long? How many combinations are possible with that? And to explore the patterns there.
Yeah.
And you've actually got, with this, you've kind of got the, it's kind of a bit like Pascal's triangle going on here. I wonder if I can show you.
Yeah, right. You've got permutations.
So you've got one way of doing it with just 1 rod. With doing it with 2 rods, you've got 2 ways. I wonder if I can fit this all in. There's 2 ways of doing it with 2 rods. How many ways of doing it with 3 rods? So you've got that way, got that way, you've got that way. Any other 3 rod ways? No.
Yeah, I'll just separate them all out a little bit so you can then see.
Oh, there's another 2 rod way, isn't there? I've missed one. There's that one. And then doing it with just 4 rods. So you've got 1, 3, 3, 1.
Yeah.
Which, if you know Pascal's triangle. Oops. Let's just draw that. Pascal's triangle goes like this. And what you're doing is you're adding the 2 numbers above. And I'm going to do it here on row 4. We get 1 plus 2 is 3. 2 plus 1 is 3. So we get 1, 3, 3, 1 on Pascal's triangle.
Really neat. Actually, I haven't seen this. Yeah, this is quite something. Yeah.
And that's a pattern that will continue. If you had chosen to just only do to not worry about different ways, different orders. Let's take that out. We only want one of these. You just have 5 ways of doing it. And these are called the partition numbers. And there are some that continue to fascinate mathematicians at all levels. I think Ramanujan did a kind of formula for trying to approximate the partition numbers. So the partition number for 4 is 5. And so it's a pattern that continues to fascinate mathematicians. The order isn't important. You don't mind about the order. Then you just have 5. So that's another set of patterns older students could explore. I wouldn't do it with young kids, but they would do this. I wouldn't try to go too far with that. I'm more interested. Can you write that in your book? I might get them sometimes to draw it, not to colour. I'm not that keen on spending a lot of time on colouring. But I might ask them to. Oops, my camera's shaking. I might ask them to write that as R plus R. Pink. That's white plus. What colour is that? Green. White plus red plus white. And this is white plus white plus white plus white. I might say to the kids after a while, would it be okay if I just write 4W for that?
Nice.
And we might start. It's one of the nice things about using colours. I can then write equations like P equals 4W. P equals 2R. Which, it's nice that it's kind of doing multiplication, isn't it? But, when I say 2R, I'm saying 2 lengths of 2, in fact, 2 centimeters. But you're kind of not having the confusion of having 2 numbers that you're trying to multiply together, which stand for 2 different kinds of things. One is the length, and the other one is the number of that length.
Oh no, there's so much in this. There's multiples.
You've got, 2 reds is just like 2 apples or 2 pens. It's just counting. And you don't need to use the multiplication sign in this. It's one of the nice things about beginning with colours. So I might, in year 1, that's with 5 and 6-year-olds, I might just start with the colours for like 5 months. And we do a bit of number work, and then after that I'd want to move on to using numbers because there's other advantages. Often we call that 1 because it is 1 centimeters, and it's kind of a unit that you can measure all the other ones with. But it's quite powerful to be able to call that anything as well. So later on, you might call this 1 and ask what fraction the other ones are. You call that 1. There's a lot about this in the book, so it's worth having a look at the book.
It's that video on YouTube about from Gateno. Call 1 anything you want, and then it is. I'll put a link to it. It's phenomenal. It really is. I mean, it's so powerful. It's all relative relationships, isn't it?
And a lot of people use the Rudd's 4 fraction work just as if you could say, pick any one of these you'd like to be 1. Okay, I'm going to pick that one to be 1. Now write out what all the other ones are if that purple one is 1. This is with maybe 8-year-olds, 9-year-olds, and more likely to do that kind of thing.
Because then you committed to having a certain value, and then everything is relative to that.
For all the other ones,
But presumably there's a phase in which it's more literal. So the white, the smallest one is the unit, and it remains a unit for a while. Or
Well, I don't ever say that. I mean, I would say, shall we for now call that one?
Right.
I think it's quite nice to say that, to say this is a provisional choice we're making.
Mm.
So I might often say, if this is one, what are the other ones? And sometimes I drop that, but I think it's quite nice to leave in the possibility that we could call that one.
Yeah.
Let's get rid of all this scribble. Any more questions from people?
Yeah, let me just have a quick look at the chat. How did Gatayano get the children to do the equations in the video, ages 5 and 6? Yeah.
That video, the one he did in Canada, he did it in English and another one in French.
Right.
It's quite astonishing.
Yeah.
I don't know whether we should aim to do what he was doing there. It's like almost like a virtuoso performance.
Yeah. No, I think that's a whole thing in itself.
And I don't know whether he had a full representative class there. And they do seem quite astonishing, the kids there. And I wouldn't aim to push them as far and as fast as he pushes them.
Yeah.
I'm happier. I'm really aiming to include everyone.
Yeah.
And I don't want to, if possible, I don't want to leave anyone out of the, now we're pushing onto ratios with year one kids. I don't want anyone to feel befuddled or confused at any point.
Yeah.
And so I'm happy to take it at a fairly slow pace, but in fact a pace that the rods make you able to do things, that it makes certain things easy. So for instance, by the end of year one, I might have these tracks. Now I haven't got the tracks with me, and the tracks they fit the rods really nicely, and they'll have little markings with numbers. It's basically a number line that they're fitting in, and I haven't drawn it in centimeters, but I'll get them to just write, maybe to put it on and to see that comes up to 3, and of course I haven't drawn it up to 3, and they might write something like 1 times 3 equals 3, and they might put the next one on and see that it comes to 6, and they can write 2 times 3 equals 6. I'm not really interested in learning those off by heart at that stage, but to get a feel of the multiplication, which they might have already experienced when we've already written, we've already written 2 green equals the dark green, which we write as D. So they've got the idea of times implicitly there. And then when we introduce numbers, we say the way we do lots of or times, well, teachers will know this at this age. We use the multiplication sign. And it's a way of just lining them up and seeing the one way of understanding multiplication is as repeated addition. So they kind of help with that. And then later on with older years, we do the area model for, can you still see that? Yes.
Yeah.
So we've got 3 times 4 here. I'll very quickly see that that is the same area as equals 4 times 3. Just as earlier on, they very quickly get the idea that 1 plus 3 is the same as 3 plus 1. It's sort of kind of so almost too obvious to remark on, but it's worth it. 1 plus 3 is the same as 3 plus 1. And I'll say to them at some point, is this always true? And, most of the 5 and 6-year-olds kind of have an intuitive feel that is, whichever way around they're going to turn this, it's going to be the same. This isn't quite as intuitive. We haven't got as much experience of this, although we know if we turn a rectangle round, it's still the same rectangle. So we have some experience of that. And that's quite handy. Then you don't have to worry about which order you write your numbers in. With a lot of teachers get quite preoccupied by that. If you kind of experience the commutativity of this, you don't have to be too hung up about which way around you write the numbers in that expression,
because the area will be the same irrespective of the order in which you and this comes up later with factorization with just two numbers, and quadratic factorization. Quads are basically a two-dimensional representation. So you're already, this is fascinating what you're doing, because you're priming them from this really young age to understand the true meaning of equality and equations and the area model, the length model, the commutative property in adding and multiplying, and these are often things we are trying to fix at secondary level. As a lot of my teaching is secondary based, so but you've got all of this happening right at that very early stage.
Talking of the area model with your carrots, I start with maybe 8 and 9 year olds. We start to look at what 2 carrots would look like. It won't be carrots by that age, will it? But this will be 13. They'll be used to representing a number most easily with a 10. That's 10 centimeters, and that's 3. And this is 2. And you see that you've got 2 lots of the 3 and 2 lots of the 10. And it's kind of the beginning of the grid method, where you've got 2 lots of 10, which is 20, and 2 lots of 3, which is 6. You add those together, 20 plus 6 equals 26. And so that's kind of my model for moving through multiplication to understand using the grid method around year 4. Lots of children will be able to do teens numbers on the left-hand side as well.
Right.
So it's a way of using area to make sense of the grid method.
Nice, really good.
Yeah.
Brilliant. We've got a couple more questions. We could address them, and then I suppose we could move on to that kind of the virtual realm on Bitpaper. Nicole Medina from the US, I believe. Is there any benefit to having a chart of the staircase on the wall?
I think maybe for like 5 and 6 year olds, when they're still not sure how to write their numbers or how to write those letters, I would do it then. Because they're still learning to write.
Yeah.
But nice question, Nicole. And so I often had little laminated sheets, so in case they didn't know how to write the letters for those rods, forgot what our convention was. You get this problem. You've got brown and blue and black all begin with B, and so we had the convention of calling this one tan, calling that one capital B and that one small b. It's a common convention for it, but it does mean it's not straightforward. Also, with young children that are still learning to write their numbers, I might do that. I think I wouldn't want to use it to tell students what lengths the rods were, because I think they could, you could say, oh, what length is the black one? And you say, can you go and just check that? And maybe get one they know and another one. And they say, oh, it's 7.
Right.
And actually, that's quite worthwhile than just going and doing that on their own and being independent. So maybe for 8-year-olds, I wouldn't have a chart like that.
Fantastic. And the other one was from Lindsay. Can you describe how you use them for triangle inequalities, please?
Okay. So, Let's just say to the children, could you get 3 rods? Let's get those ones. And could you make some triangles just using the corners of the rods? Which is a bit fiddly and not very exact and hard to see what the angle is and so on. But you'll get things like this. And at some point, you'll also get things like this, where the students will get these 3. And they'll try and make their triangle. And, oh dear, going really close. Oh dear. No, this doesn't really make a triangle. And you can kind of say, you could focus on that and say, oh, that's interesting. Isabel's found 3 numbers that don't work.
Right.
Can anyone else find 3 numbers that don't work? 3 lengths that don't work.
Yeah.
And people will come up with other ones, and you can make a whole collection of these untriangles.
Ah, nice. Nice. Non-examples, yeah.
The graveyard of untriangles or whatever.
Yeah.
And then you could start to talk about, well, why don't those ones work? What's the problem there? Why won't they make triangles? So I've also done, I've done a little bit of Pythagoras with kids. There's a lovely book called What's Your Angle, Mr. Pythagoras, which is a picture book.
Nice.
And obviously there aren't very many that you could make with Cuisenaire rods because they kind of the numbers get quite big for the Pythagorean triples. But what you can do is talk, if I don't recommend this for easy, but but if it's in your comfort zone, you can look at how the 2 squares add up to the big square, 2 small squares add up to the big one. And then I often get the kids to find on how that is a right angle. There, we did this with our year 6s. We're kind of looking at ancient civilizations, so we did some time on Pythagoras. And so I need one or more of those to be a square, don't I? And that should be a right angle in there. And then I say to the children, can you make triangles that aren't right angle triangles and check that the squares don't add up? And so we do a whole load of non-examples,
right,
and see that the angle is different. Sometimes it looks almost the same, but we see the squares don't quite add up.
Right.
So I think it's quite nice to use non-examples with things.
Yeah.
And I think probably most people that look at Pythagoras don't actually ever get to do that. And see, it doesn't always work.
No, it's a really good one, that one, actually. I've used that. Yeah. Fantastic. Okay, let's switch to gallery view. Brilliant. So yeah, we've been going for more than an hour now. So I'd love to switch over to like the virtual version of I use it on this thing called Bitpaper, which is it's an interactive canvas where I can write, you can write, and I've just built some Cuisenaire rods, and there's still some more stuff we have to cover, so we can cover that on there, which I believe we had. I can switch over to screen share, and we can look at difference factors, divisibility, primes. I think that's what I had in my menu there. So yeah, you can switch out to screen share, and then I'll explain to others what's happening here. So yeah, you can screen share. Oh yeah, once you've got it, yeah.
Okay, so if I screen share and go there, and then go over to Bitpaper. Yeah.
Nice.
So should we talk about visibility and so on for a while?
Yeah, brilliant. I'll just explain to the users that this is an interactive canvas. So Simon has it in Toulouse in his end, and I have it in London, and I'm able to pick things up and move. So I'm just gonna gently move this red one around. So that's me.
Mm.
And then
I can move one as well, so I could move this blue one.
Yeah.
I'm moving the blue one over to here.
And then Simon will ask me to do stuff, and I'll move around, and vice versa. So it's an interactive canvas where both people and two people can interact, or teacher people, or duty people, etc., etc.
Yeah. So let's get some white ones handy. Is there an infinite number of them here?
No, but I can make some more here. I've got a factory of them here.
Okay. So Atul, I wonder if you could make a train of just one color. That's the same length as that blue one. That's 90 centimeters long.
Okay. And does the orientation matter, or do you want me to just keep it vertical?
Oh, we just stay vertical as we're vertical for now. It doesn't really matter.
Right. And I'll just select from the white ones you made there.
Okay, just drag them over. I have them there handy for you because whites are a bit tedious sometimes.
Yes. Yeah. Okay. Yeah. So let's make the train. Yeah.
Can we both move at the same time?
Yeah, we can both do this together. Yeah. Many hands make light work. If you wanna go with that one.
Yeah. Okay. So I'm working down from the top.
I'll use the bottom ones. Yeah.
And I've got one. Yeah, good. Okay, so you can make the same length with just white rods.
Yeah.
And people would know that straight away. And quite kind of sort of pleasing because it's almost like too obvious, isn't it?
Yeah.
Like
it's nice.
Almost got a bit of humour in it.
Yeah.
Is there any other rod there that you could make that length with just the same colour rod? Again, I'm talking to you in your child-like avatar now.
Yeah, sure. I would. Yeah, I'm just gonna choose this little green one here and see what I can do with that.
Should I slide another one over?
Yeah.
Should we put it right next to it?
Oh yeah, even better. Yeah.
Save space, shall we?
Yeah.
We don't want to waste the Bitpaper.
It's actually it's infinite digital paper, so we won't be wasting.
It is infinite. Okay.
I've got plenty.
Can you not waste something if it's infinite then?
Well, yeah, I suppose. Yeah, it's interesting, isn't it? Yeah. I suppose it depends on the definition of waste and definition of infinity.
We'll leave that with the viewers, shall we?
Yeah, I think so. Yeah, that's one to ponder with a glass of wine or gin and tonic or something.
And should we put another one in the middle?
Yeah.
Should I drag it over?
Yeah.
See a space there, just waiting for that.
Nice.
Good. So there's obviously a lot of interesting things going on there. And one of the things I do with students, maybe this might be with 8 and 9-year-olds, is to say, what could you say about that representation? What could we write? And some of them will say addition equations.
Right.
Some of them will say they could see it as a subtraction. They could say 9 minus 6 equals 3. But some of them might see in it either multiplication or division.
Right.
And so it's got a lot of things implicit in it. And I think it's nice to start looking at in terms of multiplication and division. And we're kind of showing the divisibility. If we call that blue one 9,
yeah.
What is 9 divisible by?
Right.
And we've shown that. Can I get a pen here?
Yeah, I can just write with a pen tool. Yeah.
The pen tool. So I want that one.
Yeah, it is.
So I've got 9 divided by 1 equals. Oh, sorry, I'm writing with my. That's very messy, isn't it? You write that out.
Yeah, just that's fine. I can do that for you. It's a little bit laggy.
You write it better. Could you write an equation for me?
Yeah, it's a little bit laggy when it's screen sharing and stuff. But
okay.
Yeah,
I've got my computer pen and it's
yeah, I've got a.
Be oversensitive.
Yeah, it's the setting.
Good.
Yeah.
And you can probably write some two other division equations there as well.
So it looks like.
Okay.
So that's 9.
And we've divided it. I suppose if you divide it by itself, it's yeah, great. So they've got various equations we could see it as. So we could move into division. Often I want to take it in a slightly different direction and talk about those 3 numbers, 9, 1, and 3, being the factors of 9. And I think it's quite valuable to introduce the word factor, or divisor, some people call it,
right,
quite early on, because it's such a key understanding about numbers, really, the way they're composed of their factors. And such a powerful one for thinking about division and multiplication. So to me, it's worth 9-year-olds knowing about. And we could ask them to try it with, so we try it with 7. We don't need to do it now.
Yeah.
Can you find the factors of 7? And they'll maybe try with 2s and 3s, or some of them might know that they're not going to have any luck. And only the 1s. I won't move all the 1s over now.
Yeah.
Only the 1 and the 7 is going to work. Right. It's not going to have this multi-layer thing that we've got going on with 9. So that's quite nice to look at what factors the different numbers have. And obviously every number's got a unique set of factors. And then at some point, I think it's also worth learning about prime numbers. Yeah. And that over here, that this one, because it's only got itself and 1, half of 1, that's a prime number. Right. And I don't usually name these ones. This is not prime. Yeah. I kind of, because we've already got quite a lot of vocabulary in there, we've got factors and primes, I kind of think let's not go too heavy on vocabulary. I don't want it to be about learning words. Yeah, sure. I want it to be about understanding concepts. And that's quite, and then we often explore factorization and prime numbers in various ways. I sometimes do little factor trees with them. Do some investigations. Maybe I'm going to switch over here where you say you've got, well, it doesn't have to be with Cuisenaire rods, but it could be. Let's say you've got 24 white ones. And you say, could you make a rectangle with the 24 white ones? And then you say, okay, could you make another rectangle that covers the same area as those 24 white ones with just one color? Right. And so that's going to be 24 squares. And they'll find this one here. So we've got 6 lots of 4. Oops. Right. 6 lots of 4. They'll also find the 4 lots of 6 does the same thing. And you can put them on top of each other. They'll maybe make a 12 with like your carrot, but with the orange and the red one. Okay. And they'll find that 2 of those, or 12 lots of 2, also make that rectangle. So they're kind of exploring multiplication and division through that. They're not taking it right down to all the prime factors there, but we're looking at factors of 24. So lots of practical exploration around the idea of factors. What are all the factors of 24? And there's some people use the word divisor. That's, to me, that's really useful thinking, to be able to think in that terms. And then when we're doing mental arithmetic, we can use our knowledge of factorization to work from one known fact to lots of other unknown facts. Yeah. Fantastic. It's this comes up on secondary later on as well anyway, so this is
this is the perfect time to be just building this, the whole part actually, the vocabulary, the meaning, the various ways of doing it, equality. There's a lot going on at this early stage, and if it's embedded very, very well,
I think it's important not to rush it, not to to make it work that time, to make everyone included in it at some level, to put choice into it. So you choose some numbers now, find out what they can be divided by. So we could also we could look at the idea of remainder. So we could start with that blue one, and we could try out. Let's just grab it. We could see. So I'm on the pen.
Yeah.
I'm always doing that.
Yeah, no, you just select. Yeah.
And so the 8 doesn't fit in exactly. There's a remainder of 1, and so on. We can explore that kind of thing as a separate thing. So I'm kind of throwing in lots of things that would be very separate lessons here. And I'd also can't move that white one out because if your numbers are in the way.
So I'll just move that here. Is that what you want?
I would, I'm talking about Cuisenaire, but I would only use that, say, 1/5 of the time. I'd be doing lots of other kinds of lessons using other representations, other lines, washing lines, lots of numerical work, lots of other kind of materials. So it's always the danger when someone's kind of enthusiastic about a particular tool, how much do you use it? Well, you don't use it all the time.
Yeah.
It's important that you use it enough that children feel familiar with it and that can work comfortably with it. But you also want to see that these things are embodied in multiple representations, that you can see the same thing in many different ways.
Yeah.
And also to keep the pace at the right pace. You don't want to kind of rush through. Now we've learned this, we can learn this, we can learn this. Well, if you build that minimally, the structure is not going to be very strong. So you want to build each stage in multiple ways if possible. You've got a good solid base on which to build.
Yeah.
I know I'm talking to teachers who know this really well, but I suppose it's important when you hear someone that's an enthusiast, and I am for Cuisenaire rods.
Yeah.
That I know it's not everything, and I would I use a whole range of materials, including online and virtual materials.
No, it's just sometimes, I've done that many times. You can discover a new way of doing things that might be two-sided counters or Cuisenaire rods or algebra tiles, and for me, I just get carried away with it. I was like, that's the only thing I want to do for a while, because as I discover it.
I haven't particularly noticed the students get fed up of it. I think they like the hands-on, and they like the power of it, and that you can see so many different relationships through what we're doing. And it often is very open-ended. If you say make rectangles, some of them will just make really long rectangles and just explore that. So they'll all make a rectangle that's 24 long but use different coloured rods,
right? Which
is itself quite interesting. And some of them will make the sizes, and then some of them will put them in order and see that there's a kind of curve emerges when you put them next to each other. So they can go all sorts of ways with. And I kind of like to leave it a little bit, to make it permissive, that you are allowing at least an open middle, if not an open end. That people can take different journeys through the same lesson.
Yeah, I like that expression, open middle. Brilliant. I'm just looking at any other questions. They've kind of fizzled out a little bit. People want links. Obviously, we'll put links to everything. The books we mentioned, virtual Cuisenaire rods. There's loads in there. Okay, we're kind of wrapping up there, so maybe you can remove that screen share, and it'll be just me and you and your Cuisenaire cam, which which we've improvised. Actually, it's not a document camera. But,
No, it's my phone on a stand.
Because the school's shut and you weren't able to access your visualizer, I believe. So,
No,
yeah,
I have those at school.
But yeah, I'm amazed the technology is held up. I mean, you're in a remote area.
Yeah, I'm really pleased.
Yeah. Except for the first minute of me, they're not being able to hear me, but I can edit that out and we can go straight to the bit.
Yeah. Okay, we've covered a lot of ground. I don't want to throw in too much more. I think we've done quite a big tour of the territory there.
Yeah, we have. Yeah, that's a lot for people to absorb and think about.
And Atul, you use them a fair bit with the people you're working with online, don't you?
Yeah, so I teach completely online. That's my default, 100%. So in fact, that's how I got to know you. Actually, parents were sending me pictures of what their children are doing. I was posting pictures on Twitter of what I'm doing, using both the virtual and real ones. I was the first one to do it really online, and brave/foolish, whatever you want to call it, to do it. And I noticed that I didn't know about you at the time actually, but you started taking an interest in this how on earth I'm doing all this stuff.
Yeah, I think it's lovely what you do with the Bitpaper in that both people can manipulate it. That's really exciting as a possibility.
Yeah, I mean, it's not a Cuisenaire tool Bitpaper. It's actually a writing canvas with you can draw some shapes of different colors. I made them as rectangles, but yeah, it's that two-way interactivity. I get my because a lot of tutees don't have the Cuisenaire rods, or they may order it, or it might not arrive, or I just want to do a little bit with Cuisenaire rods, not a lot, so it's not worth buying. So I'll just use that.
Even in class, I kind of move between students at tables with physical rods and coming together to look at the big whiteboard, interactive whiteboard. And sometimes I'll have taken photographs of what they've done at the tables, and I'll call them back to look at the photo, and we'll annotate the photo because I want to move to that writing stage, and also just to discuss it. And sometimes I'll use one of the Cuisenaire apps to, that allows them just to pull them around and do what we were doing on the Bitpaper.
Right.
So even within a situation where I've got physical ones, I do also want to. It's quite hard if you have everyone sitting at their tables and you try and address the whole class when they've got Cuisenaire rods. It's quite hard to keep your hands off. So it's quite nice to come away from the physical manipulative for a while and just contemplate maybe one image slowly.
Yeah.
Like that one with the 9 and the 3s and the 1s. And there's so much kind of juice in an image like that. You can just say to the students, tell me the ways you can see that. You can write a whole page of equations with them just by contemplating one image without any moving about.
Yeah.
I think those times of stillness where you're just observing, contemplating, slowing the whole thing down are really valuable.
Yeah, that's fair. That's a sweet spot of learning. Yeah. So yeah, fantastic. So yeah, we can just wrap up there. Thanks so much for your time, Simon. I know you are really busy. But I feel it more as a beginning, really. This whole online realm and just connecting with yourself and showing how this works.
Very good.
So it's in some ways.
Perfect interview.
Yeah. Brilliant. So I'm gonna stop.
You've been willing to have a go as well.
Yeah. I'm raring to. Yeah. No, it's all good. So. Yeah, so I'm gonna stop the stream now, and then we'll just have a quick chat and debrief to finish up. Okay, thank you everyone for tuning in. Video will be there.
Thank you.
Just yeah.